Well, pre-calculus classes, most likely good afternoon. And first, sorry I'm not able to be there. I had to be next door at central office at a meeting and would definitely rather be there with you guys. But did want to first finish up the notes that we started on Tuesday. I know as the bell was getting ready to ring, especially for 7th hour, we were talking about how obviously complementary angles going back to geometry or before are two angles that add up to 90 degrees. Supplementary angles are two angles that add up to 180 degrees. Now using those radian values, when we talk about complementary angles, they would need to add up to pi over 2, excuse me, and supplementary angles need to add up to pi, which is 180 degrees. So, first, when it says here, if you're thinking about, okay, a 47 degree angle, what would you need to do to find its complement or its supplement? Well, what would add up to 40, or what would add with 47 to get 90? Well, 47 plus 43 is 90. So the easy way to figure that out is you're going to subtract. So working with the value pi over 5 and then also 5 pi over 6. Well, what we'll do is for pi over 5, we'll do both the complement and the supplement. I like to start out, the complement, pi over 2, we're going to take pi over 2, subtract pi over 5. Same thing for the supplement, pi minus pi over 5. Again, I'm going to put that over 1. Well, for both of these, we are going to need common denominators. For the complement, multiply 5 over 5, 2 over 2. So then that gives us 5 pi over 10 minus 2 pi over 10, which when you do subtract those, the complement, 3 pi over 10. Very similar for the supplement. Now, this one's actually a little bit easier here. We only have to worry about a common denominator for pi, since pi over 5, already has that. So for this one, since we don't really have to worry about actually doing any multiplication to get that common denominator, 5 pi over 5 minus pi over 5, the supplement of pi over 5 is 4 pi over 5. So there is an example there, very similar, 5 pi over 6. Well, complement and supplement, subtract from pi over 2, subtract from pi. Again, we'll do that over 1. Now, this one's actually nice because for both of these, we will actually only need to multiply the first one. So here, multiply by 3 over 3. Here, 6 over 6. Well, this one, you end up with 3 pi over 6 minus 5 pi over 6. Well, we do run into an issue on this one. And, if you think about it, 5 pi over 6 is right here. If you look at degree equivalent is 150. Well, 150 degree angle does not have a complement. It's already bigger than 90. So this one does not have a complement. Down here, 6 pi over 6 minus 5 pi over 6 is just pi over 6. Which you can see if you look directly across 5 pi over 6 and pi over 6, those are the supplements. 150 and 30 add up to 180. So the final thing that we're going to talk a little bit about is, whenever we work with radian degree measures, we always kind of, we're working with a circle. And I will admit a lot of times we do kind of compare things to, the hands moving around a clock. Well, if you think about it, we can treat 1 degree as 60 minutes or an hour. And then what we'll often do is we'll treat a minute as 60, or a minute is 60 seconds. So that means 1 full degree, to really refine it, if there are 60 seconds in a minute, 60 minutes in an hour or a degree. Well, 60 times 60 is 3,600. So a lot of times when we work with degrees, we can really refine those down to, parts of 3,600. Now, when you've been working with degrees up until now, pretty much have been decimal degrees, 54 degrees and 45. When you see this symbol, this is 54 degrees, 45 minutes. Down here, this one is negative 128 degrees, 30 minutes, and 15 seconds. Well, for these types of questions, I do actually think you'll find it probably easiest to work with a graphing calculator on these. But, certainly when I return, I can show you where these functions are on your scientific calculator as well. They do all have it. Graphing calculators do work well. Now, if you're converting from decimal or from degree, minute, seconds like this into decimal degrees, there it's simply a matter of it's 54 degrees and 45 minutes out of 60. So all you're going to do is take 45 divided by 60, which is 0.75. So this is 54.75 degrees. If they happen to give you one where, it is in both minutes and seconds, negative 128 degrees and 30 minutes out of 60 plus 15 seconds out of 3,600. Now for this one, don't actually add these values on to this. What you're going to do is take 30 over 60, which yes is a half, plus 15 out of 3,600. And when you do that, it is 0.504167. For this, if you go to like 3 decimal places, that's fine. So that's going to be negative 128.504. And we'll say it's approximately negative 128.504 degrees. So if you're converting from minutes or minutes and seconds into just decimal degrees, all you've got to do is some, division, treating again as parts of either an hour or I guess for both of them, it's parts of an hour. 60 minutes in an hour, 3,600 seconds in an hour. Now, if you're going from decimal degrees back into degrees, minutes, and seconds, that's where you're going to use your calculator. Now, what you're going to do is first enter this value in to the calculator, 15.126, and then your angle function, you're going to press second, and then if you're using a graphing calculator, the third row down, second column over, the apps button, you'll notice right above it says angled. So you do second, and then apps, and when you go down to degrees, minutes, and seconds, it's the fourth option down. I know my calculator here is having some issues with the graphics, but it's that fourth option down, DMS, and it will eventually tell you what the value is, although apparently this one is not working so well. There we go. It is all right. Well, first, sorry about some technical difficulties. Luckily, I happen to have a second graphing calculator at home. So apparently that one is in need of possibly even a new backup battery. All right, so what you're going to do is enter in the 15.126 decimal degrees. Again, you're going to go second, and then the apps button. Now you can actually see everything that's on the screen. Go down to the degrees, minutes, seconds option, and it will tell you, once you get there, you hit enter once more, 15 degrees, 7 minutes, and 33.6 seconds. So this is one that you obviously will need that calculator for. So again, 15.7 minutes and 33.6 seconds. So 1 marking for the minutes, 2 markings for the seconds. All right, so for the rest of the time, obviously there is the work on Pearson. You can now, begin for this section. The other thing that you've got some time for today, if you want to hit pause on the video and grab a few different items, you will need a protractor, and then you'll need the purple and yellow, and then the white sheet. The white sheet actually kind of has some of the directions that you're going to need, and I'll kind of talk about this a little bit here as we go, but you will probably only need one side of the purple. There does happen to be a second side just in case as you're working with the protractor, if there is an error and you need to, you can always go and, work on the back side of that. Now, as you read through here, basically, as we work through Chapter 4, we're going to use the unit circle quite a bit, and this is something that's not going to actually be due for a little bit while, but since I'm gone, this is actually a good day to kind of have you get started on this. I'll certainly be able to answer questions for you as you go with this when I return, but what you're going to do is with your protractor, on the purple page, what you're going to do is place the center of the protractor right there, and then line up the, kind of that line with the protractor along the x-axis. And then what you're going to do is we need to mark off every 15 degrees. Now, when you do that, I know a lot of you had that refresher on how to use a protractor when we did that other kind of investigation activity. And what you're going to need to do is mark off every 15 degrees going around the circle. And then we'll kind of talk about how you can get the other half of the circle as well. Now, what I find is probably the easiest to do is starting here at 0, going around the outer edge. So there's 15, there is 30. So if you notice, 30 is there, 15 is there, then next 45, 60, then 75. Now, obviously, the nice thing, 90 is already there. Next at 105, then 120. Next would be 135, then 150, and then last 165. Now, from there, these markings are past the circle. So what you want to do is line up the protractor with the center, and at each one of these, draw from the center through that mark, because I know it does actually go past the circle, and we do need to make sure you have each one of these drawn from the center out, so it at the very least crosses the circle's circumference that's on the purple page. And then once you've done that, I'll show you one other thing that we're also going to do with these, because we are going to want you to even mark the bottom half similarly. Now, the good news is you do not need to go through with the protractor and do that. What you can do is extend each one of these lines that are raised, whatever you want to say, that you've already drawn through to the corresponding. So basically you're going to have a bunch of circumferences, or I'm sorry, you're going to have a bunch of diameters. You're going to, just from the center, use what you've already drawn, and like this. And then once you've done that, we'll talk about what you're going to do with the rest of the white page, and then even get you started a little bit with the yellow. And you will need a calculator, certainly for the next part of what we're going to do. Now, some of it's going to be just some simple estimation, but for one of the items that we're going to have you do, you will need your calculator for when we take the y divided by x value. Now, you can see each one of these intersects the circumference of the circle. You don't necessarily have to make a dot there, although I do find it kind of helps with the estimating. Now, if you notice, it's 0 degrees. They filled in some of the table for you. The x value is 1. The y value is 0. When you take the y value divided by the x value, 0 divided by 1 is 0. That's this point right here. Now, the next one. They have given you rough estimates already. We'll see how what I just drew compares. But if you notice, this one is between 0.9 and 1. Estimate here, 0.96. So I'd say that's pretty reasonable. And then here, you can see this one is a little bit above 0.2. They had an estimate of 0.23. The last thing that you're going to do is take 0.23 divided by 0.96 and, just round it off to the nearest hundredth. You do not need to be any more exact than that. Now, we'll go to 30 degrees. I'll kind of show you doing this now with the points that you just drew. So here was 15. If you want to even label that, you can. 30, 45, 60, 75. Up here is 90. 105, 120, 135, 150, 165, and then I'll stop at 180. Obviously, you can continue around the circle if you want. Now, at 30 degrees, right here, if you estimate the x value, it is somewhere between 0.8 and 0.9. If you want 0.85, I mean, I don't want to say there aren't wrong answers to this. I mean, you don't have to be exact. I mean, there's no way to know for certain. If you said this was 0.3, that's a bad answer. But 0.85 is fine. Now, if you look at 30 degrees going across to the y-axis, honestly, it looks like it's right around 0.5. Then last, you're going to take the y value divided by the x value. And this is the good calculator. So 0.5 divided by 0.85 is 0.59. All right, I will do one more of these, and then I'll show you how that yellow page will come into play. So the 45 degrees, the x value, as I bring that down, honestly looks like it's just past 0.7. So, I don't know, maybe 7.2. As I go across, it looks like maybe just below 0.7. Okay, so 0.68. And then divide those as well. 0.68 divided by, ooh, there's a negative in there, 0.68 divided by 0.72, 0.94. All right, so that at least gets you a good start on filling these in. As I said, if you want down here, 195, 210, again, you can finish that up. Doesn't take real long. As far as how you're going to use the yellow sheet, there are going to be three things that you use it for. Now, first, if you notice, there is a graph for each part of your table. Along here, you can see 15, 30, 45, 60, 75, and so on. Now, what you're going to do at 0 degrees, your X value was 1. So at 0, I'm going to have a point at 1. Then at 15.96. I know some of these grids don't print off real well. 15, you can see, is just barely below the value you've got. Next, at 30.85. So there's 30.85 is kind of right in the middle there. And then 45.72. So there's 15, 30, 45.72. Again, these aren't going to be perfect as long as you are in the vicinity. And as you go, you actually might find it helpful to even connect them. Eventually, they will make a smooth curve when you do connect them together. As far as the Y values down here, it's going to work very similarly. You're going to use the degrees, and now you're going to use your Y value column. So 0, 0, then 15 is 0.23. 0.23, a little bit above 0.2. Then 30 is 0.5. And then the last one that I kind of got y'all started with at 45.68. So that puts us right about there. And again, if you find it helpful as you go, you can kind of connect. One reason why you might find that helpful is if you're connecting them, makes it a little bit easier to do your estimations. So there's one final graph. You notice this one on the back is a much larger grid. There's a reason. Some of these values, as you do the division, will get a little bit bigger. Also, you will not have enough room here for all of these. So 15, 30, and it's perfectly fine. Eventually, we'll talk about why it is that you don't have quite as much space along here. Now, going up, again, you may not need to mark these, 0.2, 0.4, 0.6, 0.8, 1, and so on. I think if you use a grid like that or a scale like that, you probably will be good. All right, so to finish up, at 0 degrees, your Y divided by X value is also 0. At 15.24. At 30.59, so that one's actually pretty close to. Again, I do apologize. I know some of these grid lines did not print off very well. Unfortunately, that's the unfortunate thing with some older copiers. And then last, 45 degrees, 0.94. So here's 45. This one, if you want to even label them all as you go, 45.94 is closer to 1. So somewhere around there. And once again, if you want to connect those as you go, you can. Certainly this at least gets you a good start. You can use your time for the rest of the block to continue on with this. Like I said, there is also the assignment on Pearson. Whatever you want to do with the rest of your time this afternoon is fine. I will be back on Monday. We'll continue to go over section 4.1 then. I'll actually have a new note packet for you guys on Monday. But other than that, have a great weekend, and I'll see you all Monday.